Flavio Junqueira is a committer to Apache ZooKeeper. Flavio, welcome to Software Engineering Daily.
Hey, thanks, Jeff. Thanks for having me.
Apache ZooKeeper began as a sub-project of Hadoop, but was eventually spun out. What problems does Apache ZooKeeper solve for Hadoop?
So for Hadoop today, it solves the problem of pretty much mass selection for the name nodes in HDFS.
Did it solve more problems in the past?
In what sense? For Hadoop, you mean?
So did people used to use it for a wider array of problems, or has it always just been mainly about leader election?
Not really. So it's about a number of things. I think mass selection is a pretty typical use case. Lots of products end up using mass selection and other things as well.
And how would you define master election?
Well, so you have a number of processes in your application, and you want one of them to arise as a leader and perform some master tasks on behalf of the cluster.
And why is leader election so important to a distributed system?
Why that's important? Because a lot of the designs we have, they're based on the master. You have some sort of head nodes that makes decisions on behalf of the cluster.
Does the leader form a bottleneck if all the clients have to serialize their processes through the leader?
It could be, but you don't have to have a single leader in the cluster. So, for example, if you have a Kafka cluster, each of the partitions will have its own leader, right? So you don't have to have one single leader for the whole cluster. So you can have, say, different entities. In the case of Kafka, you have this topic partitions, and you can have a leader for each one of those. So it doesn't have to.
Do the multiple leaders, do they form a hierarchy, or are they just all leaders that are on a similar tier of responsibility?
No, they're independent. So in the example I mentioned, the example of Kafka, so each leader is a leader for a partition, and it's independent of the other partitions.
And what guarantees does ZooKeeper enforce?
Guarantees. So ZooKeeper guarantees that once you get an acknowledgement of a right, let's start with rights. Say you create a Z node. Once you get a response for that, an okay for that, it means that the right is durable, right? So even if servers crash and come back up, you still see you're right there. It also guarantees that all rights are totally ordered. So if you write to a Z node, and later on you write again to that same Z node, so everyone is going to observe the same sequence of updates to that Z node. It also guarantees that everyone who reads the state of ZooKeeper will observe the same sequence of updates. They might not observe at the same point in time because the updates they propagated synchronously to the servers, but they will observe the same sequence.
And so for somebody who doesn't have a much background in distributed systems, so the guarantees that you just stated, why are those correlated, or why are those enabled by the idea of leader election? They're
not enabled by the idea of leader election. So it turns out that the core of ZooKeeper, all it does is guaranteeing you a consistent view into the updates to ZooKeeper. It doesn't tell you anything about master election. It's almost by accident that master election ended up being so popular, because it's not something that we have embedded into ZooKeeper. So if you look at the ZooKeeper API, there's nothing about master election, right? But again, because there are so many systems that are designed with this idea of having a head node or a manager, and that manager needs to be fault tolerant and needs to have some sort of reliable repository for metadata, that ended up being something like ZooKeeper.
Right. Okay. So could you talk more about ZooKeeper's API? Just explain maybe the core. What are the core, the most important functionality pieces of ZooKeeper's API?
Yeah. So you can essentially you manipulate Z nodes. Okay, and Z nodes live in a hierarchy of Z nodes. So you can have a Z node, and that Z node can have children, and the children can have children, and so on. With the API, you can create Z nodes, you can delete Z nodes, you can change the data of Z nodes conditionally, which is a very powerful feature. You can read the state of Z nodes, so you can get the data of a Z node. You can get the list of children of a Z node, and you can check if a Z node exists. So those are the basic or the core 6 calls that ZooKeeper offers for you to manipulate the Z nodes.
And how do people use that API to develop leader election?
So you're asking for explicit recipe how you would do that?
Well, you said it's almost an accident that people ended up using this API for leader election. So I'm just curious, like, how did that accidental implementation manifest?
It's not accidental in the sense that it's not allowed. It's in the sense that you have lots of recipes. You can implement locks, you can implement barriers, you can implement master election, you can implement a number of things. And master election turned out to be one pretty popular. Again, because many systems are designed like that, with a master, with a manager. Now, how you do master election there? So the simplest way is to create a Z node. So you create a Z node. If you are able to create it, then you are the leader. You are the master. And it works because if someone else tries to create it, remember that the rights are totally ordered. If someone tries to create it, the create's gonna fail, and so you know that someone already holds holds leadership, right? And another feature that is important, I think I didn't mention when I was talking about the core API, is that the Z nodes can be ephemeral and or sequential. So ephemeral in the case of master election is important because if you say you go there, you try to create the master lock Z node, and you can't because it already exists. You say, okay, cool, there is already a master. But that master may crash in the future, so I want to be informed if that master goes away. So when the client creates the master Z node, it makes it ephemeral, which means that anyone who is interested in learning when that Z node goes away, because the client has gone away, can subscribe to that, to notifications. Right, to a notification to the Z node or about Z node.
And when Z nodes are watching each other, how is that watching implemented? Like, how does a ZooKeeper node become aware that something has occurred on another node in the data center?
So again, you create a Z node and you say, I want the Z node to be ephemeral. And another client, if the client is interested in the status of that initial client, it reads the state of the ephemeral Z node and sets a watch on it. Okay, and so let's call the clients A and B. Okay, so A comes and creates an ephemeral Z node. That ephemeral Z node is associated to the session of client A. If client A crashes, its session are going to expire. ZooKeeper is going to detect that and is going to delete the ephemeral Z node. Now, if client B is interested in what's going on with A, it can set a watch on that ephemeral Z node. And in the case the session of client A expires, B can be notified of the event because the Z node is going to be deleted automatically by ZooKeeper.
Right. So users can also manage configuration using ZooKeeper. Is ZooKeeper used more for configuration of failovers and leader election, or is ZooKeeper also used for application level configuration like user data?
Yeah, so if by user data you mean like the end users of your online service, like
yes.
So I would say it's not a great idea to do that because that's more like bulk data. So that's more suitable for data stores that deal with bulk data. And ZooKeeper is really more about metadata about the data, right? So, and ZooKeeper is really good with small data updated infrequently, which is typically the case with metadata about the data, not the data itself. But so if you're after examples of metadata, right? So I can give you a few. So in the Kafka example I mentioned before, you have metadata about topic partitions. In Storm clusters, you can ZooKeeper is used to manage the cluster, for example, stopping and starting workers. So Solar Cloud uses that to manage a shared metadata. Bookkeeper also in the category of log replication like Kafka. It stores ensemble metadata in ZooKeeper. There's also service discovery and registration like companies, for example, Twitter and Pinterest have described in blog posts. So things like that are examples of metadata that have been successfully stored in ZooKeeper and used in production.
Those are super useful examples. So how does ZooKeeper actually store the data? Because I know that it's different than how the data would be stored in just like a key value store or how a database stores data. So when you say that ZooKeeper stores data, what is the underlying process there?
Right. So ZooKeeper keeps the state mainly in memory. It keeps the data tree in memory, but it also writes to disk in two ways. It writes a transaction log, so every time you submit an update and that update is processed, the servers need to log to the transaction log, and periodically servers they generate a snapshot of the data tree and also write to disk.
And explain a little bit more why ZooKeeper is useful for a system that has many reads but fewer writes.
Right, because we can. It's sort of easy in ZooKeeper to scale read throughput, but not as easy to scale write throughput. So to scale read throughput, you just have to add more servers. In the form of new followers or new observers. Followers are the ones that actually vote in the replication protocol. Observers, they just learn the result of the replication. And so if you add more servers, you can increase your read throughput capacity. But that's not the same with the writes. If you add more servers or more voters, you're actually reducing the write throughput capacity. Right, because every time you write, you have to write. You write to all servers, plus you need to wait for votes or acknowledgments from a quorum to be able to make progress. So that makes the writes more expensive.
And if I update something on my ZooKeeper cluster, how does the update propagate to the other ZooKeeper nodes?
Okay, so the path is more or less like this. So you as a client, so you have a client, you submit a request. A request goes to the server that the client's currently connected to. Let's assume that it's a follower. It's not the leader. The follower forwards the request to the leader. The leader generates a state update, so essentially transforms the request into an idempotent transaction. Then it proposes that transaction to the ensemble. It waits for acknowledgments from a quorum. So that acknowledgement essentially tells the leader that it has been written to a disk of a quorum. And once it receives that, it sends a commit message to the ensemble, and whoever got initially the update from the request from the client, once receives this commit, informs the client that the operation has succeeded. Does that make sense?
Great. Yes, that makes complete sense. Do people use ZooKeeper as a message queue?
Not really.
Okay. What about a notification system?
Yeah, so it has been used as a notification system.
Okay, is that an appropriate implementation, or is that something where it's not the best use of ZooKeeper?
No, I think a notification service is a good use of ZooKeeper. I wouldn't say it's a bad one. So message queue. The problem with message queues is if you're trying to create many of them, it won't be. You're going to induce a lot of writes into ZooKeeper, so the workload's not going to be great, right? So your throughput, your performance is not going to be great if you do that on top of ZooKeeper explicitly. But that's part of the reason why people have designed and implemented systems that do that on top of ZooKeeper.
Right. Okay. So I want to talk a little bit more about ZooKeeper in the present day. How does the implementation of ZooKeeper compare to, like, if you could reboot ZooKeeper today and start completely from scratch, is there anything you would do dramatically different?
Okay, dramatically different. There's one thing I wish we have, that I think we could have done differently. These days is more evident that we should have done it. At the time, we started thinking about it, but we didn't make a lot of progress, which is having ZooKeeper more designed as to be like used as a service, right? So I think the multi-tenancy features of that we have for ZooKeeper today are not sufficient to have it used as a service, and there are things that we could have done differently to make it better in that direction.
Can you elaborate more on that? What do you mean by the multi-tenancy problems?
Yeah, so if you can have one ensemble shared by say multiple tenants. Say that you have a company, you have multiple products that rely on ZooKeeper, and you want to share one ensemble across 2 or 3 products. The problem is that today there's really no guarantee that one workload is not going to affect the other, right? And sometimes writes to ZooKeeper they're sort of sensitive to latency, and you don't want the workload of one tenant messing up with your own workloads. There's the security issue as well. So you want to make sure that data is not accessible by other tenants. So we have ACLs, but I think we could in the case of a real multi-tenant environment, you would need to have stronger security features, right? To separate the data of the different tenants.
Interesting. So are you saying that if ZooKeeper were more were built more as a serviceable, or a platform that could be made as a service, security would be one potential service application?
No, I was referring more to securing the data that the different customers or the different tenants are storing in ZooKeeper.
Oh, okay, I understand.
Right. But another thing to be said is this: if you have different tenants, they most likely don't need their requests to be ordered together. Right. So right now, one ZooKeeper ensemble is going to offer you an engine to order everything that goes through it. So it's a single engine, right? So everything is ordered together. So if you have multiple tenants sharing the same set of servers, you can then you have to go through the same ordering engine. Of course, you can try to deploy multiple instances of ZooKeeper on the same servers and use different ports and all that kind of stuff. But the problem is now you start having to separate the disk traffic as well, because we rely on a dedicated transaction log device for high performance. So what would you do? Like, you use multiple disk drives and one for each of the different tenants. starts becoming tricky to do in practice. So we could have done something along the lines that we did for ZooKeeper, right? So aggregating the logs of different, say, clients and storing that on the same disk, but that's not what happens today.
Does the usage of ZooKeeper differ at all in real-time or streaming applications versus like batch applications?
So I think in general, and it's beyond streaming, near real time or online or offline, whatever you want to call it. So I think it's beyond that even. It's more about having instances of something and needing and having the need to store the metadata for each of those instances in somewhere in a reliable fashion. So again, if you have a Kafka cluster or some cluster, you need to know the workers that are there, the different workloads you're running, perhaps different customers even, and separate all that and store that metadata in a reliable repository. Not only reliability is important, durability, but also consistency as well.
Right. Okay. So you've mentioned the Kafka example several times. Has the usage of, or has the synergy between Kafka and ZooKeeper, has that changed over time, or has that stayed pretty static? How Kafka uses ZooKeeper?
I think it has evolved. It has evolved in a number of ways. I think I think the core thinking around how to use ZooKeeper to sort the metadata for topics and partitions and so on. I think that's pretty much remained the same as I understand it. I'm a bit new to the community, so someone in the community might have a different thinking around that, but that's my understanding. But there are things that end up changing because I realize that there's a better way perhaps to use ZooKeeper, to leverage ZooKeeper to do a particular task. But again, in general, I think the high-level thinking pretty much remains the same.
And so I'm curious. You say you're new to the Kafka community. So what is that in terms of just a community and how you contribute to a open source project within the community? What are some tips for how you get acquainted with, if you're for example, you've been working on ZooKeeper for a long time, and now if you're getting involved or you're interacting with the Kafka community, what is that process like? Do you have any suggestions on how to be a good communicator as a representative of one project communicating with representatives of another project?
Yes, that's an interesting question. But I'm finding the experience very interesting because even though Apache Kafka and Apache ZooKeeper and even ZooKeeper for that matter, they're all Apache projects. They are very different communities. The way of dealing with changes, dealing with contributors, and managing the community in general is fairly different. So one thing that I believe is important is that if you're interested in the community, just go and interact with the community. I know that sometimes it's hard because people are not super responsive, but that's not because they're evil. It's just because all of us have day jobs as well, and we have to do stuff. Because I've seen lots of complaints on Twitter, for example. No one responds to my Jira. I posted this like a year ago, and no one has said anything. It's kind of unfortunate that these things happen, but so if you put some pressure, you typically end up getting some answers, especially if you put some effort into it, right? So another thing that I strongly discourage is that people go out there and complain about projects. So even though we talk about projects, we're really building communities here, right? So if there's something you don't like, try to contribute back and make it better. I mean, it's part of making it open source.
Absolutely. What are the differences between a open source community and the community within a company, like the ethos of a company versus the ethos of an open source project?
Yeah. Okay. So that's an interesting one. So
because you mentioned that there's every open source project has its own ethos, has its own personality, and I think that's also true from company to company. If you work at Google, it's a different attitude, a different ethos within the company than Facebook, for example. But my question is more about what are the general differences between ethos within a company versus ethos within an open source project?
Yeah. So I think in the open source community, one big difference is we are not in the same organization. We're all contributors to the same project, and each person or each group involved in the community will have different preferences, different priorities, and managing that is probably one of the big challenges of an open source community. In companies, there are typically goals that need to be met and so on, and everyone needs to be on board, and so there are clear guidelines of what you should be doing. Where in the open source world, you're always trying to accommodate the constraints and the requirements of everyone.
So let's talk about another couple projects. So how is ZooKeeper used in an architecture with Apache Mesos?
Okay, so I haven't interacted much with the community. I know about Mesos from reading about it. As I understand it, he uses ZooKeeper essentially for leader election and advertising the master to the members of a cluster.
Okay, so there's nothing like totally groundbreaking or unexpected in the intersection of ZooKeeper and Mesos that you know of?
Not that I'm aware of.
Okay, what about the interaction of ZooKeeper and Docker?
Yeah, I'm not aware of Docker directly using ZooKeeper. I know that there are applications that have been they have their own Docker files and such for ZooKeeper because they rely on ZooKeeper. But that's pretty much it. So I have read about the Swarm product, which has a manager, and I've talked about some Raft backend for master election and log replication, but that doesn't sound like it's going to be using ZooKeeper.
Okay. Yeah. I mean, do you know if there's any inherent difference between managing coordination among Docker? I mean, would you manage coordination among Docker images versus managing coordination between actual machines? Or maybe that's not a domain you have any expertise or understanding in. But
well, so
maybe there's.
I can see the need of coordinating these things. So you have, again, as you said, you have different machines and you need to deploy containers, and maybe you want to be fault tolerant and not only fault tolerance, but maybe you want to do load balancing and move, shuffle containers around. And you could use a component that is based on ZooKeeper or something that is ZooKeeper-like to do it.
Right.
Yeah, so I totally see why one would do that.
Interesting. Okay. So, you've been around open source for a while, and I'm curious about the rate of innovation in the present day and how that has changed relative to the past. Is the amount of innovation and new products in the Apache space, is it growing to the point where it's like too big to follow everything that's going on in the community?
Yeah, that's a good question. It probably depends on which community you're talking about. So if you're talking about Apache in general, I would definitely agree with you. So I am not exposed to everything that Apache projects are doing. Actually, I would say that I have a very narrow view of what's going on in Apache. But inside communities themselves, I think they try as much as possible to be to provide visibility across everything that's going on, and so it's not too hard to have an idea of all the topics that are being covered, all the efforts that are going on. even if you don't know the exact code or you have reviewed the exact code that is doing it.
What are the areas in the open source community, at least in the domain that you focus on, that are really exciting to you right now?
Yeah, so especially because I've been working with Confluent right now. I find this area of stream processing very exciting. We have been talking about stream processing for a long time, but I don't think there is yet a great solution for corporations to just deal with stream processing in the right way. And so I feel that Confluent is going to develop something that's really cool, and I'm happy to be participating in that. I also think that all this container effort that you mentioned is super exciting. There is, Docker has been great to sort of create this hype and interest around containers. People are super excited about doing it, and so there's a whole set of tools and a whole number of mechanisms being designed in the container space, and I think that could change the landscape of how we deploy applications, right? Not only data centers, but in the cloud and all that.
And so, what I actually did an interview with a Confluent employee, and it was really interesting. So, what is exciting to you about Confluent? What is exciting to you about Kafka?
What's exciting to me about Confluent and Kafka? So Kafka is a piece of technology that has worked very well in production. Like the number of successful use cases. Even when I was working for Microsoft, we had use cases of Kafka internally, and I think I do see a great potential in using that Kafka core, to build a great stream data platform, and that's exactly what we're trying to do in Confluent.
And there's been an explosion of managed big data companies that offer a paid, serviced version of these various Apache projects. Like for Hadoop, there's Cloudera and Hortonworks. For Kafka, there's Confluent. For Spark, there's Databricks. One of the themes I've encountered in the interviews this week is that the modern data center is made really complex by the fact that you have all these managed providers, and if you're a guy in a data center, you have to work with support people from each provider. So I'm curious what you think about this. How will the interactions? I mean, how are the interactions in the present, and how will they change in the future between managed big data companies like Cloudera and Confluent and the companies that purchase these products?
Yeah, that's a good question. So I think companies like Cloudera and Hortonworks, so far as I understand it, they have tried to cover as much of the space as possible. Even though they brand themselves as Hadoop people, they do offer a number of other services. So they support ZooKeeper, they support Storm, and all those things. It's a valid concern. I'm not sure I have a great answer to it, but I'm not sure it's very different from the situation of data centers today.
Yeah, you know what's interesting is the idea of Cloudera or Hortonworks trying to cover the entire ground. I wonder sometimes if they're spreading themselves too thin, because it's not it seems like they're kind of going for this tight coupling strategy in an environment that's kind of exploding in like a Cambrian explosion of just different products. I wonder if it's risky to as a product strategy to have to try to cover all the bases of the quote big data platform. Yeah,
I see it slightly differently. So if you're spread too thin, as you say, it can become a problem because you promise that you're gonna support a given system, but you just don't have enough to actually do it. So if you start specializing, then you can create partnerships to do this. But then sure, then there's a problem that you're mentioning before. You have too many players in the game. I guess the challenge there would be to find a way of creating these partnerships without actually overwhelming customers.
Yeah, it's an interesting tension. So you started a company recently called Rescale Limited. What are your plans for the company?
So right now, I don't have a big vision for the company. It's essentially a company I have started to be able to work with others, and in particular, I've been working with Confluent. That's my main commitment right now through this company.
Interesting. Are you focused on ZooKeeper, or is it just distributed applications in general? It's
this stream data platform. The company is that I'm working with Confluent.
Interesting. How does building a company compare to just working on open source?
In what sense?
Well, I mean, when you're building a company, you're building something, you're building a product, and you want to sell it. So I mean, you're selling your services. So it's sort of different than working on open source, where you're just building something with less of an intent. So I guess what I'm interested in is the creative process of building a company versus the creative process of contributing to an open source project.
Yeah, so if you are contributing to an open source project, so when I started participating, I was in a research organization, and so the research organization itself didn't have any sort of requirements with respect to the open source project, other than just helping others to build their own products, like with ZooKeeper. But we were supporting internal properties that had their own requirements and goals. And so if you're contributing, most likely you have your own requirements which are probably coming from your customers. And this is not very different from starting your own company. You have your customer needs express his or her needs, and you have to fulfill that through the open source, if that's what you're doing.
Why didn't a company ever form around ZooKeeper? When you see this explosion of companies that have productized open source projects, why didn't ZooKeeper ever evolve into a company?
Yeah, that's a great question. I think it could have evolved. It's just that us doing the project never got together in a way that we could do it. I think it's just how things played out. It's not that it's at least in my view, it's not that it's not worth it. It's not that the project is bad or anything. It's just how things played out for each one of the individual players involved in the project.
So what do you think are the things that people would pay for around the ZooKeeper space? Like, what do you wish was in the marketplace that customers could come and pay for and say, hey, I want ZooKeeper plus this?
So in companies I have worked for, there has always been specific questions or asks around ZooKeeper. Not all of them ended up going into the open source project. Like when I was in Microsoft, there was this wish of offering ZooKeeper as a service, and as I mentioned, we don't have all the mechanisms necessary to actually make it happen. And so I think a lot of companies that use ZooKeeper, they end up getting frustrated because they hear about ZooKeeper, they think they can use it, but sometimes they don't know the best ways of doing it. There are companies like Cloudera and Hortonworks that provide some support, but my understanding at least is that it's not their core business. So
I have a Oh, go ahead.
I was just going to, just to wrap up, a company around ZooKeeper would essentially offer that, so consulting, helping other companies to leverage ZooKeeper to do their own kind of business, and perhaps extend to features that are necessary to those specific lines of business.
So I think there's an interesting interplay between academia and business in the world of distributed systems. Are there any projects in academia that you find exciting right now? Or I don't know how closely you track academia, but is there anything that's kind of on the bleeding edge that you notice that is exciting to you?
Yeah, so there's one project that I have participated. I don't think it's in the stage that you're referring to. I don't think it's even close to being ready. But it's this project that we have done trying to harden distributed systems. So the idea is that the systems we do today, and that includes ZooKeeper, they tend to be crash fault tolerant, right? So they tolerate crashes. But if you have things, if you have, for example, data corruption, so your hardware corrupts your data. So the fault tolerance that exists in those systems won't protect you against it. And at the same time, redoing algorithms might not be a great idea because that requires proofs of correctness, and it's a bit of a pain to redo all these things. And so we were thinking, can we derive a scheme so that we can take existing systems and make them more robust automatically, harden them, And so there is this project that we have worked on that's called Libsei. That's for again making distributed systems that are crash tolerant, making them automatically robust to state corruption.
Fascinating. Is there a page or any information on that I can include in the show notes?
There is, yeah. So there's a repository on Bitbucket. I
Awesome.
think if you search for Libsei, Libsei, all one word, then you should be able to find it.
Fascinating. Okay, cool. So, talking a little bit more about ZooKeeper, the algorithm. So as I understand, ZooKeeper is backed by Paxos. That's correct, right? Or something similar to Paxos.
It's Paxos-like, yeah. It's called Zeb, the protocol.
Zeb, right. Could you talk, have there been any algorithmic breakthroughs in leader election, or are the Paxos family of algorithms, are those still pretty much the gold standard?
Right. I like to think of Paxos, and I don't think I'm alone in that kind of view. Paxos is more like a meta protocol, in the sense that it gives you the foundation for building a replicated state machine. So that simply means that if you take the protocol described in the paper, that's not enough to do a real system. You have to think about all the messages and all the things that have to go around it to make it actually work. One of the things that Paxos didn't do out of the box that we had to think a bit more carefully about is the fact that we wanted to propagate idempotent transactions as opposed to commands. So the whole state machine replication approach is based on the fact that you agree on the sequence of commands that the replicas execute, right? But we didn't want the replicas executing commands. We wanted them to apply state updates. And so that requires a few changes in the protocol, because now the commands that are in your stream of agreed upon commands, they're not independent anymore. So there's a dependency because, so I generate a state update, and then the next state update is going to depend on the previous, and so on. So there are some specific or special requirements from the protocol that you need when you're doing those kinds, when you're propagating state updates as opposed to commands. And Zeb was essentially a protocol to do that.
what is the future of the data center, and what is the future of distributed systems? You're at the forefront of working on these projects. Where do you think the macro environment of the data center and the distributed system is going?
Right. Okay. So there are two things that come to mind. One is software-defined anything. Right. So there's this trend to make everything like storage and networking software-defined. And the other one is density, which is essentially the container movement. Right. So making data centers denser. There is also there's a third thing that just occurred to me that I think it's quite important, which is the fact that I think soon we'll have things like non-volatile RAM being commonplace in servers, and that if you start using that with for example RDMA, you can start having systems that operate at super high speed compared to what we have today. Fascinating.
And so you mentioned Docker. What define data center density?
Oh, right. If you're using just VMs, I think the density of VMs per server today isn't very high. And I think one of the goals with containers is to actually make it a lot higher. Right, so I guess we're talking. I guess the difference is pretty dramatic. We're talking from like tens to hundreds and even thousands maybe. Right, so with VMs having like tens per server, a server hosting tens of VMs versus servers hosting like hundreds of containers instead.
And so, as I understand, the big breakthrough of Docker was not necessarily the containerization technology itself, but rather the usability layer that's on top of the containers. Is that correct?
That's how I feel that as well. But I would say that it has popularized the container utilization. But I think you're absolutely right. It's more about making it easier to use.
Do you find it interesting that if it's essentially this usability layer on top of this thing that's, it's classically been super useful. Like I was talking to Eli Collins of Cloudera, and he was saying, yeah, we've been using containers for a really long time. It's great that Docker has made this popular, but these have been around for a long time. Does it make you wonder, what other technologies are there out there that are potentially super useful, but can't be used because they're not, I guess they don't have a good usability layer on top of it?
Yeah, and I think there is a human factor as well, in the sense that I've seen great projects that just don't fly because they don't have that special person who goes around advocating for it, So I think
that's true.
Yeah, I think there's just a lot of great technology out there, but if you don't get, if you don't have someone in the team that is very good at pitching it and talking about it and convincing others, then it might never fly.
Yeah, and I guess it's also about the API, right? ZooKeeper has become so popular. Maybe part of that is because the API is so good. You could have a much worse, much more complex, burdensome API, but it's much more user friendly.
Yeah, of course. Yeah. So if you do the pitch without the technology being good, then of course there is no you don't get a good outcome. So I agree with you. Yeah. So ZooKeeper, the API of ZooKeeper has been clearly one of the things that made it successful.
That's great. Okay, so to close off, I want to, as a motif of Software Engineering Daily, is to get an idea for how people can become better at working on projects on their own and be focused on it, because I think it's actually, I think software engineers aren't as autonomous, aren't as self-driven as maybe they should be. And you're a perfect example of somebody that's worked on several projects. You've led several projects, and so I guess I'd like to get some idea of what are some like psychological ways that you can become that a developer can become better at improving their ability to work on difficult projects on their own?
Yeah, unfortunately, I don't think I have a recipe for that. I think one advantage I've had is the fact that I've been in research organizations, for many years, and that kind of risk taking attitude is pretty much mandatory. And so we had to come up with new ideas, and because I was working in industrial labs, they were often being motivated by real problems that we were getting from broader groups, and yeah, so that's how we ended up, or I ended up being involved in all these projects. And also was super lucky of being in Yahoo during the time that all this big data movement was sort of flourishing, right? So was coming up, and so we did ZooKeeper at the right time. So it was good to be part of that environment.
So my last question, is distributed systems more of a philosophy or a science?
Oh, I don't know. I can tell you one thing. I think actually some colleagues and I have been talking about this. So distributed systems is at a stage that I guess there is research to be done, but we have a lot of systems out there that work, right? So you see distributed systems everywhere, right? So as you're using your Facebook or Twitter or LinkedIn or whatever social network you like, or whatever online service you like, that's being served by one or more distributed systems. So we do see these things working in practice. That's different from the kind of stuff that you go to conferences, and you don't see as many of those in your daily life. I don't know. So I don't know if it's fair to say. I think it's like computer vision and so on, which I think that there's still, even though you do see some things around that in products, it's mostly still in the research space. So there's probably a lot to be learned still.
Okay, fascinating. Well, Flavio Junqueira, thank you so much for coming on to Software Engineering Daily. It's always fascinating and enlightening to talk to you. So yeah, thank you so much.
Yeah, thank you, Jeff.